This conference will now be recorded.
Okay, so yesterday we did RTP, but as it always happens for the first time when you are trying to understand the concept of RTP, it appears to be complicated or a bit confusing, uh, but actually it is not so because whenever you do it for the very first time, we feel that way, but otherwise it can be understood very easily. So whatever work we have done yesterday, I will explain in a different way, more from the layman point of view, so that you understand it conceptually. And when we do it in the system, the billing, that time you see the RTP analysis. So there you get a picture what was the role of RTP interface. Now basically what is this interface? Let me explain in a very simple way so that we can move forward with the work what we have done yesterday, and then based on that we will be able to create our rate what we want to create. Now you see, in the case of the smart meter, the interval meter, we have the data stored for every 15 minutes during the period of time. So this consumption will be, data will be for interval of 15 minutes. So like I said in the previous session, we have data something like this at morning 8 o'clock, 8:15, 8:30. Okay, so we will just do one small thing. So let's say midnight. Here midnight it may not take. So 15. So like that as 0.15. Okay. So here you see this is almost like 24 hours where we have the data which we got in fact up to here. So let me just remove it. We'll be using such kind of data later on also. That time will be, I will have some data to show you how that data will be created. Basically the interval data. Now here we have the data. Let me just say I have some consumption here recorded. For just purpose of explaining, I'm taking some constant value. It won't be like that. So let's say 0.32. Okay, 0.32. This is a consumption value. Every 15 minutes we have got the consumption value till midnight. Okay. Now this data will be stored in the form of a profile. Where will the profile be created? The profiles are created in EDM, that is Energy Data Management. So if you go to EDM and then Profile Management, Profile Header, let me show you some profile header what we created earlier. We'll be creating soon for us also. So let us assume our file header installation. We can go to the profile itself, find the profile for the division, let's say 30. Okay, 30. You can also find out today whenever you are free. You can take 30 or so and so. Profile for 2694 meter. This is a profile, and then select. This is a profile header. This will have the values actually. Values are stored. This profile is assigned to the meter RG001 register This profile 121 is assigned to the meter 694. 694 is a smart meter. It has got a register 001 and the profile is 121. Now, as you can see here, this profile has got a kind of a data description, what it will be storing. So let us say profile number 121, profile values, display, profile value 121. Of course, today's date there won't be data available, but it can be stored. Okay, right now it will show 00. Like this, you can see 00, midnight, 12:15, 12:30, 12:45, 1 o'clock, 1:15, 1:30, like that. Okay, here the values will come and set. Okay, now how to build this data? Because if it is a single value like in the regular conventional meter, we just say quantity 01, the value will be taken from the register because our rate is register enabled, and then price is stored in the facts, quantity into price will be the amount, and the value is calculated. But here you have got 24 values in a day, 24 hours into 4, 96 values in a day, and like that it could be 30 days. So 96 into 30, you can imagine the amount of quantity that step by step we have to build. So we cannot do like one after another. So ideally speaking, what we want, interval data is there. If you want to just build at one single quantity, what would you have done? Simply add up the value. Okay, starting from this to end, if you know the value, you simply add up every 15 minutes interval data. It will give you the cumulative value. Starting from the 1st of January till 31st of January, continuously data you have, you just add up, you get one value, multiply with the price. But then what is the advantage of using the smart meter? If that is the case, we would have done anyway with the regular meter. But ideally, why we have chosen smart meter? So that we come to know two things. What is the pattern of consumption? How the consumers are consuming the electricity? And also, the rate of consumption will not be uniform throughout the day. It is not like average 0.32 all the 24 hours, all the 30 days. It won't be. It will be varying. So at some point of time, the rate of consumption may be more. Okay. At some point of time, the rate could be moderate. At some point of time in a day, it could be very less also. Okay. So considering that fact, we would like to divide this data into time of usage. Okay. But basically, what we do is we divide this data into the time of usage according to RTP design. Okay. That means what outputs you want to get. Suppose let us assume the company is building only on peak and off peak. That time you require only two types of usages. What are the periods in which on peak is happening? What are the periods off peak is happening? But in our case, we are going to use the three times of interval because we want three different outputs: on peak, mid peak, off peak, and the on peak, mid peak, and off peak. Okay. Now demand also you want to build. Demand means maximum peak. Sorry, maximum peak you want to build. Okay. Now, how to get this quantity? For that purpose only, we are designing the RTP interface. First, you design the time of usage that we know. There are three types of usages. We have put them into time of usage group. And then we created two RTP component. One RTP component is going to give us three values. That is on peak, mid peak, off peak. What is the purpose of RTP component? We can understand from layman point of view, RTP component is the one which analyzes the data. You have it in the interval data in the profile, and based on the logic, it will give us some discrete quantities. Okay. So in our design, on peak, mid peak, off peak, the component is going to give three values: on peak, mid peak, off peak. How does it give? Actually, in the RTP design, we have used one formula called copy 01. Okay. This copy 01, what it will do, it will create two output profiles in the background. It is stored temporarily and system will use it, but we will see later on how these formula profiles are actually working, how they work or how they create it. Okay. But while the billing execution happens, these profiles are created, but you won't be able to see the data, but it will be shown in the form of a curve. It will be shown in the form of a pattern. Now what this copy 01 will do, it will copy this data as it is. That means it will copy this data as it is. Let's say copy, and then create one more profile. Create one more profile. That's the energy profile. That's the energy profile. That means as it is, you can see the data is copied. Let us say this profile is 121. Okay, this profile is 121. What we have actual input data, but in the working, during the process of working, it will create one profile 122. Okay, let's assume system will create one profile 122. It will have all the data, whatever you have got in the input profile. Now it will create one more profile in the background. Let us assume it is 123. In this profile, it will contain the demand values calculated. How the demand values are calculated? Let's say this copy and then put it here, midnight. Now here, this will be is equal to 4 into 0.32. That is 1.28. Why 4? Because all our values are 15 minutes. So energy is equal to demand into our time. Okay. This 0.32 consumption, why it has happened? Because some X demand has run for 1/4 hour. 15 minutes means 1/4 hour. So what is the power of that equipment? That is yes, demand. That is equal to 1.28. That means if you run a bulb of 1.28 watt for 15 minutes, okay, that means how much is the consumption? It will be 0.32, like that. Okay. So this particular thing is also created in another profile. So that profile will contain the demand values. That profile will contain the demand values. Okay. Here everywhere it is 1.28 because our this thing is same. Okay. Now our RTP component 60, okay, which is having a time of usage group as 6000, which is having the time of usage as 3, on peak, mid peak, and then off peak. That component will have input profile data. That is, this input profile will be assigned on the RTP component number 1, that is on peak, off peak, mid peak. And then what is the output? Output is it's going to work on this output copy of 01. Copy 01 means copy of this data. This data it will take in the period happening in the on peak. Let us say this is on peak. Okay, this much data it will take, and then we are using some function. So then it will say the output is on peak. Output is on peak, X value. Okay. Similarly, in the same RTP component, we've got the time of usage, which is happening in the certain other period of time. So that will be taken into consideration, add it, and then you will get the off peak. Okay. Then or mid peak. Let us say it is mid peak. Mid peak is going to be Y, like that, off peak. So basically, this RTP component will have the input profile data, but because you are using copy 01, what it will do, copy of consumption quantity on that profile, it will look into, and then it will add up all the values which are happening in the on peak, sum it up, and then one particular output is derived, that is on peak quantity. Similarly, the RTP component will work on the copy 01 profile 122, segregate the data which is happening in mid peak, and then say this is a quantity. Okay, and then 122 profile it will again add, and then it will show this is a total consumption quantity. Okay, then second RTP component, what it will do, it will have the same input profile data, but now it will consider the copy of 01 second file, second profile. Among all these values, it will look into, take one value which is peak. Okay, let's say for example here the consumption was 2.3 kilowatt hour. If it is 2.3, then what will be the value? 2.3, 2.3, let us 2.3. 2.3 is equal to, here we'll put it, is equal to this value, sorry,
9.2.
this value into 4.
9.2.
Yeah. So 9.2. So the 9.2, yeah, correct. 9.2 will be the peak value. So the second RTP component will take the value as 9.2. That is a peak. The first component will work on the interval data, add up, and then give 3 individual quantities: on peak, mid peak, off peak. And second component will look into the data. It is not bothered whether it is an on time or mid peak or off peak. All that it requires is one peak value. Okay. So basically, I hope you understood the job of component. The component is the one which has got time of usage, and based on time of usage group, we have got the time of usage. When the components are included in the interface, it will help us to use the existing interval data, and then using copy 01, it will create two profiles. So the input profile data is same for both the components, but the first component will be looking into this data, the copy of the NH data, analyze it into 3 times of intervals, and then add up the data which is there in the on peak, mid peak, and off peak, and then it will give 3 resulting parameters. Likewise, your second component will look into the profile number 123 example. Take one value which is the highest value, and that is the output of the RTP component, RTP interface. So in our RTP interface design, this is what we have done yesterday. So we have now fixed the components what we are going to get. With this information, let us see whether we can create our rate. Okay, so let's go to create the rate. Just one second. Okay, so let's go to rate. Select the billing. Define the rates. Create the rates. Now let us say our rate is Z601. Now here we are going to select the interval meter. This rate is designed permissible to work for the interval meter. So if we select the rate permissibility as interval meter, then it will ask what is the interface we are going to use, because whatever quantity operands you are putting in the rate, those operands should get the value from the output of the RTP interface. So unless interface is entered here, we cannot create the rate. So but the moment you select interval meter and continue, this field will open. Okay, that means this field is grayed out in the case of all other situations, but only if you select the interval meter, this field will open. Now we have got our interface ready. 600 is the RTP interface, and then continue. Now go to rate steps. Now here we are going to use quantity 01 3 times, because 3 values we are going to have: on peak, mid peak, off peak. And then we will have here demand 01. Now sub transactions all will remain the same only. There is no change. all this data will be same only. Operands are going to be different. First, you'll put the all the operands, then you can put the other things. Now, input operand, this is on peak quantity, on peak price, on peak amount. So if you select here, it will show 500, okay, on peak quantity. And then 503 is the mid peak quantity. And then 506 is the off peak quantity. But when you select demand here, the input operand value will be demand, not the quantity. So it will show 509. So these are the quantity and these are the prices: 501, 504, 507, 508, 510. So here it will be 501, here it will be 504, and here it will be 507. And then here it will be 510. Okay. And then actually here 502, 505, 502, 505, 508, and then 511. So these are the outputs amount. Now here statistical line items are available. That means every month when you do the billing, it will first show what is the quantity for the line items. On peak is so much, mid peak is so much, off peak is so much. Then it will show the value items, but here no info lines are available because the maximum. Period control is up to the day, so it is 00. And then check for consistency. No incases are found. Now set. Now before creating the schema, we will finish some more work in the case of rate. Now generally when the rate is executed, we will have two operands, quantity and price. Based on that, amount will come. The quantity, how system is taking in our present situation, every month we are doing the meter reading and meter reading results we are entering, and that result is updated in the installation, and then that value will be read and then taken into billing. Price, how it is getting from the facts. Okay, but in our case, this quantity, whatever you have for meter reading, it is not something what we have entered manually. It is something which is there in the profile, but then it is the RTP which is giving the sum total quantity for the billing. That means in this particular rate, if you see Z601, and if you go to rate steps, this 500 is the quantity. From where this information will come, how much is the quantity for 500, how the system will assign, not based on the metering result what you are entering in a regular fashion, but actually this 500 will be nothing but the first output of the RTP analysis. Okay, the RTP, what you have designed interface, the first component is the on-peak quantity. That value should be assigned to 500. Okay, that means the 500 should get the value which is corresponding to the first output of the RTP interface. But how does the system knows that? Because there are three outputs and three quantities. So this connection we will give it in the facts. Previously we maintained facts at the our what you call installation level. We also maintained at the rate category level, but this time we will see how to maintain the facts at the rate level itself. Okay, now before we maintain the complete connection between the operands and the facts, we will first maintain four prices. One will be on peak price, one will be mid peak price, one will be off peak price, and the demand value. Okay, now once the price keys are ready, we will assign them to the facts. So this time it's not only the price that we assign to the facts, but also the quantity, because quantity also we have to give the corresponding connection with the RTP output. Okay, so for that what I will do, just come back here. Now go to change rate. If you go to change rate And then if you select here, rate steps, facts. So here, fact group is 001, let's say residential customers, and then continue. So here you can see these are all the operands, okay? 500 on-peak quantity, 503 mid-peak quantity, 506 off-peak quantity, 501 maximum demand. But right now it is showing this particular quantity has to come from the RTP output. It is showing red mark. The value is not existing. That means all these quantities have to come from the RTP. We have to give connection with the RTP interface, okay? Prices we have to maintain and assign. So let's create the prices, then I'll show you how we can make the connection between the operands and the RTP what we have designed. Okay, so we will go to define the price keys. So select the billing and then go to billing master data, define the prices, create the prices, and then first price is quantity based price and currency INR. Pricing type is, let's say, standard. RTP on peak price energy. So billing class is Z601, division is 60, unit of measurement kWh, kilowatt hour. And then go to history, and then starting from 0101 2019 till 31st 12 999, and the quantity base is 1 kilowatt hour. So let's say 15 rupees per kilowatt hour is the price. This is for the on peak price. So now copy this and then save it. So we have created one new key, price key, which is for basically the on peak prices. That is 116 is the price key. So like that, I will now create one off peak price, one mid peak price, and then the demand. So 116 you have created, come back, create the prices. So quantity, INR, standard, enter. So here we will say RTP of mid peak price, and then everything remaining same. Go to history, then 0101 2019 till 31st 12 999. Quantity base 1, 15 rupees for on peak. So let us say 12 rupees for mid peak, and then copy and then save it. Come back again, create. Price type is standard. So here we will say RTP off peak. So go to history and then 0101 2019, valid up to 31st 12 999, and then quantity base, let's say 10 rupees, and then copy and then save it. So 116, 117, 118, three price keys are created. These are for the energy. Now we will create the price key for demand. Okay, the demand prices are maintained as time dependent price. Time dependent price means in the general quantity we have got connection only with the quantity, but in the case of demand it will also have a relation with the time. Okay, so we can express the time dependent price in so many ways. We can say it is going to be 20 rupees per kilowatt per day. We can say like that, or it can be, let's say, 600 rupees per kW per day, or let's say 7,000 rupees per kW per 1 year, or per, let's say, 1 year, that is 365 days. I mean, we can express it in kilowatt and 365. How actually demand values are calculated? Demand values are calculated like this. Suppose for the complete duration, the peak demand is coming to 22 kW. Just theoretically, throughout the month when you see The maximum peak demand, which ran for 15 minutes, is 22 kW. Then how the demand value is calculated? Demand value is equal to the demand into the price, time dependent price, into number of days of billing. How many number of days of billing we are doing? Number of days. So in our case, let us say 30 days. So maximum demand has come to 22 into 20 rupees per kilowatt per day into 30 days of billing. So 30. So the demand value will be 22 into 20 into 30. That will be 22 into 20 into 30. So the consumer has to pay 13,200. 13,200. But they also have to pay the energy amount. Energy amount is calculated based on the quantity into price. Let's say the energy value is coming to 10,000 or let's say 15,000. That means they have to pay 13,200 plus 15,000. So this particular price what you create is a time dependent price. It is got per kW per day. Okay. So now we will do the time dependent price, create here. Price category, quantity, but here you have to take demand. That is a time dependent price. And then it is standard price. So here we will say demand or max peak price. Max peak price. Now Jet 601, 60, but unit of measurement will be kW. Now because it's a time dependent price, we have to select the time basis. We'll select it as day. I'm giving it as per day. Okay, it is for 1 day. And then go to history. And then I will say 0101 2019 till 31st 12 999. Quantity base per kilowatt, it is, let us say, 30 rupees. And then copy. So this 30 rupees is not just for 1 kW, but it is for 1 day. Depending on the number of days, you will multiply with the peak value what you have got, then you get the demand value. So now we will save it. So this will be 119. So all the 4 price keys are now created. We'll go back to the rate what we have and then select the rate and then change the rates. Go to change mode, select the facts. Fact group is residential customers 0001. Now on peak quantity, this 500 is the quantity operand. What will be the value of this? This will be connected to the first output of the RTP interface. That is 1. 1 is the first output. That is a on peak quantity. So double click, valid from 0101 2019 till 31st 12 999. And what is the resulting parameter of the RTP interface? It is 1, on peak quantity. In the RTP interface, we said there are 4 outputs. First 3 outputs are coming from the first RTP component, and the first resulting parameter is on peak quantity. We copy, transfer, and then 501 is the on peak price. So for that, we have created just now the price key 31st 12 999, and the price key is 116. So here you can see it is going to be 116, 15 rupees, copy. Now go to 503 0101 2019 till 31st 12 999. Here resulting parameter number 2 from the RTP interface, mid peak quantity, transfer, then mid peak price 0101 2019 till 31st 12 999. Here the price key will be 117. That is our price key, and then transfer. Now the mid peak price. So right now we are doing the mid peak. So 0101 2019 till 31st 12 999. The resulting parameter is the mid peak quantity, mid peak price. So mid peak price is already given. Now we will go to the off peak quantity. Select the off peak quantity 0101 2019 31st 12 999. This will be the third output, that is off peak quantity, copy, and then off peak price 0101 2019 999. Here the price will be 108, 118, and then transfer. Now we connect the output of the second RTP component, that is the peak demand. 509, double click, 0101 2019, 31st, 12999. The resulting parameter here is the 4 max or peak demand, and then transfer, and then we will give the demand price. Double click, 0101 2019, 31st 12 999, and the price key is 118, 119, 30 rupees transfer. So now you can see every connection has been given. Previously we used to give only the value in the facts, because the quantity will come from the installation, because every month you are doing the meter reading, entering the result. Naturally it will read that value and take into consideration for billing. But in our case here, we don't enter any results. Results are actually available in the profile. And on the profile, the RTP interface is working, and it is giving us 4 outputs. So those outputs are assigned to the particular operands what we have in the rate. So when the billing is executed, the RTP interface also executed. It will determine the 4 outputs: on peak, mid peak, off peak quantities, and the demand, and they are assigned to these operands. And the price key we have already assigned, what price it should take. So based on this information, it will calculate 4 amounts. Okay. So the RTP rate is having all the information, the quantity part and also the price part. So now we will save it. Once the rate is ready, we should be able to create our schema. So go to schema, define the schemas, create. What is schema? Schema contains one or more rates, but in our case there is only one rate. So Z601, on peak, mid peak, demand. 60, Z601, schema steps. Insert the rate. If you know the rate, you can insert here, or you can find out. We want the rate to be used here, which is permissible at the interval meter. Okay, so select X, permitted interval meters, and then execute. So Z601 is the rate available. Select it. So it has copied all the 4 variant programs which are there in the rate. Now we have to give here the pre-sorting keys. So pre-sorting key 0002, 0002, and then check for the consistency. It is consistent. Now save it. Once the schema is ready, we'll design the rate category. Basically, rate category will go and sit in the installation. So go to the rate category, define the rate category, create the rate category. Z601, division 60. RC for smart meters, and then outsorting check group is 0001. Our billing schema is Z601, and then save it. Now rate category will go and sit in the installation, but rate type will be maintained at the register level. So based on the rate type and the rate category, rate has to be determined. So now we will set up the rate determination. Go to define the rate determination. So if in the installation level, the rate category is Z601 and the rate type is Z601, what should be the rate? Create. So it is always with the time. Effectively from 1st of January 2019, we want to use the rate here as Z601 and then copy. That means once you create an installation, do the device installation. While doing device installation, we will have the rate type at the register level of the device. Based on the rate type and installation rate category, rate will be determined. So all the 4 variant programs will be stored in the installation, and they will be executed when the billing will happen. Okay. So our billing master data is ready. Now RTP interface we have designed yesterday, but one more RTP interface I'll create just to show you how we created yesterday for your understanding once again. So go to You can try it if you're not tried yesterday. You can do it today. Energy data management, interface to RTP billing, define RTP interface, create. So RTP interface, I'll call it as Z. Yesterday I created 600, so I'll take it as 601. This is only for our understanding. Whatever we created already has been adjusted with the rate. Okay. So this interface I'll call on mid of peak and max demand. Formula for profile calculation, I'm using copy 01. Okay. What is the role of this formula? It will work on the interval data, input data 122. Okay. And it will generate two profiles in the background. Profile number 122, 123 in our case, just example. This profile will have the data as it is copied from the energy profile. And this will have the demand values calculated for each interval by multiplying with 4. That's the actual functionality of this particular formula. Interval length is 15 minutes. Division is 60. Okay, division is 60, and then enter. So this is our header level data. Now resulting parameters. If you use this interface, what you will get? It depends on our design. So in our case, we want 4 outputs, 3 energy quantity, 1 demand value. The first resulting parameter number is 1. The unit of measurement is kWh, kilowatt hour, and we want to call it as on peak. This will be on peak. Now this value will be assigned to an operand. We have assigned just now in our rate. The operand was created for the operand category quant. Quant is a general quantity, so it is quant. It is quant here. And resulting function. Resulting function means on the output profile, whatever you have got, this has to add up. Okay, depending on the time of usage, it has to add up the value and then get the output quantity. So resulting functionality is sum. We have to select it as sum and then copy. Likewise, resulting parameter number 2, unit of measurement is kWh, but now we'll call it as off peak quantity. And this is also quant, this is also sum, copy. Resulting parameter number 3, this is also unit of measurement this, but this will be mid. This is actually off peak quantity. Previous was mid peak quantity, so we will change it. Description, we will copy this. Now before that, we will go to this one. The second is basically mid peak quantity. This is the mid peak quantity, and then copy. So mid peak quantity is already copied. It has been changed. Okay. So there are 3 outputs here. 1, 2, 3. All are basically going to be connected to operands with the quant, kWh, sum function. One is on peak quantity, second is mid peak quantity, third is off peak quantity. The resulting parameter number, we want to now get it as 4, and this will be kW. This will be kW, and we will call it as max or peak demand. And then this will be assigned to operand with the category demand. Okay, and then resulting function is the peak value. It has to take the maximum peak value, copy. So we have got 4. That means in this output profile, it will study all the data, whichever has got the highest value. Like we got some 9.2 or something, that will be the value will be taken for the output. So we have fixed the resulting parameters. But in order to get these resulting parameters, we want to make use of 2 RTP components. One is designed as on peak, mid peak, off peak. One is the maximum demand. So now we will include the RTP components. The first RTP component we want to execute is, that is 60. That's the priority number 1. And then continue. Include it, insert it, select the insert component, insert the component into RTP interface. Effectively, it will be from 0101 2019, and then copy. Then the second RTP component we want to use, that is 61. This will be priority number 2. enter, insert, and it will be also valid from 01/01/2019, copy. So two RTP components we have included in the RTP interface. Now we have to make the connections. What will be the input and what will be the output? Okay. So if you go to this, you can see 60 is the RTP component, 61 is the RTP component. Open this. Now here you can see on peak usage type, mid peak usage type, off peak usage type. Open this. The consumption profile quantity, copy of the consumption profile. What is the consumption profile quantity? That's the input. In order to calculate the on peak, off peak, mid peak, you require first the actual interval data, which is measured for the meter. That will be available in the profile, that is input profile, which is assigned to the meter. This is 121. Okay. So this profile, we have to add it as an input data. So double click this. It will come to input parameters, valid from 01/01/2019. And then here, instead of assigning the profile, we are assigning a role. That means if any profile has been assigned to the meter with the particular role, then that will work as an input profile data. So select the role here as consumption measured. So when you are assigning the meter to the profile, we will see we will be using this particular role. Select here and then copy. So now input is given. What is output parameter? Output parameter is copy of the consumption quantity. That is this profile. On this, it will only look into the data according to time of usage, that is 6001. Okay, 600, which is on peak quantity. Okay, that means it will work on the output profile data 122, whatever is the profile. It will add up only those values which are happening in the on peak usage type, and then resulting function is sum, and based on that resulting number will become number 1, that is on peak quantity 001, and then copy. So now you can see both are turned into green. Copy as demand profile will not be applicable here, it will be applicable only in the last case. Okay. Now go to mid peak, select the consumption profile quantity input. So again 01/01/2019, and then roll 0001, copy. So this will be working on the output parameter for the time of interval 6001. Select the copy of the consumption profile quantity, and the resulting parameter number here will be 2. That is the mid peak quantity, and then copy. Now we'll go to the off peak and then select the input. Input is again same, that is 01/01/2019. The role is 0001, and then copy. And then output will be the sum total of the energy quantity happening in the off peak period. So resulting parameter number will be the 0003, and then copy. Now we'll go to the second RTP component, and then here we will take input profile. Consumption profile quantity is the same. The same energy data input profile will be assigned for the demand also, but based on this, it will have the second output profile, which will contain the demand values. So here, our input profile is also role assigned with 0001, and date from 01/01/2019, and then copy. And here there is no time of usage. Why? Because the max value can come at any given point of time. We don't know. It may come during the morning time, in the afternoon time, in the night time. Okay. All that it will do is study the entire duration consumption quantities for all the durations. Take one value, which is the peak value. So now we will say here role is 0001, copy, and then go to copy of consumption quantity not required here, because here it is going to look into this profile, which is the demand value. Okay. So we have to select here copy as a demand profile, and the resulting parameter number will be our 0004, and then copy and then save it. That means we have included the RTP component, two of them, into the interface, and then you are given the connection between the input and the output, and we are using the formula allocation as a copy 01, which will work on the interval data, generate two profiles. One profile will contain the energy data, one will contain the demand value, and the component is basically going to study the consumptions happening in the time of usage. And depending on the sum functions we have used, 3 outputs will be generated. And the fourth output will come from the second RTP component, which is studying on the copy of the demand profile profile, and then take one value, which is the peak value, and then pass it on to the RTP. Now save it. So now if you go back to change RTP interface 601, and then if you go to this, time of display. Now, as I mentioned here, the total consumption profile quantity will be segregated into time of usage. This is happening in the midnight, from midnight 1 o'clock to next day morning. So here this is on peak. So let us select time of display. Yeah, in the output you have to see here. Input is all just continuous. But if you go to the output, you can see from midnight, that is 1 o'clock to 6 o'clock. That means 6:59. Okay. All this data will be basically, the off peak. Then it is starting with on peak, and then it comes with the mid peak in the afternoon. Mid peak is shown with different color legend. Okay, this is red, this is light blue, and then off peak will start from 7 o'clock. Okay, so this is shown in this color. This is the breaking period, midnight to next day. Okay, so it is also off peak. You can see the same color legend is used for the color legend which is in the off peak period. So off peak and this demand will be the same, and this will be the design. Okay, so this is lighter, and this is this is less. This is actually dark blue. This is not actually dark blue. It is somewhat blue color, light blue. You can differentiate when you look it in the system. This is having a color legend which is slightly light blue, but this is it is more darker, identifying this as the off-peak period. So off-peak is happening during two intervals, 7 o'clock to midnight, and from midnight to next day morning 6:59, and then 7 o'clock to 1 o'clock 1:59 will be the mid peak, and from 2 o'clock to 6 o'clock 6:59 second, it will be the mid peak value. So you must see the three different color legends so that our design is correct. So then whatever we did just now, creating a rate and interfacing that with the output will happen. Okay, but when the billing execution happens, we'll be able to see the complete information. What is the energy quantity, how the graph is there, outputs, how the profiles are shown, how the demand values have been added, how the values have been summed up. All that information you will see in the billing in the RTP analysis. Okay, but the profiles, whatever you see here, these 122, 123, they are all temporarily stored in the system. You can't see them as output. Okay, the only input profile is 121. So to know how actually it works, I'll be showing you profile value calculation separately in example. We'll use two formulas. One is a copy 01, one is a limit 02. So two profiles I'll show you how the formula profiles will work. There are four types of profiles. That is the profiles used in EDM. So all the four profiles we'll be studying. First, we'll be using the regular profile. That is basically elementary profile. Where the profile is available, we will add the value. Then we will have the synthetic profile, day profile, and the integral profile. So altogether 5 profiles are there, and formula profile. Elementary profile, synthetic profile, day profile, and then we have the what you call formula profile and integral profile. So all the profiles we'll be studying. Initially, we'll be working with the elementary profile. Okay. So we have completed the rate part, and then we are ready with the billing master data. Tomorrow we will create our installation and then assign the rate category, and then we will do device installation. Okay. After device installation, we come to the rate is determined. Now we have to introduce one more technical master data that's called point of delivery. So far, we did not use a point of delivery because we are not having the idiom. So in technical master data, we'll be creating the point of delivery. We will see what is the purpose of that. And once the POD is created, we have to assign to the meter. That is the register of the meter, so that we can say our technical master data device management data is ready. Then we'll do the moving, contract is prepared. Then we'll create a metering order. But then how will we get the value? So we will create a profile assigned to the meter and put some test data, maybe for 2 or 3 days for all the 24 hours, and then we will execute the billing. Okay. So tomorrow we will complete the remaining master data and then start working on the EDM profiles, create one first profile, and then after you execute the metering order, we'll put the data in the profile. I'll have some test data. We'll put it in. It will be there in the Excel sheet. We'll put it into our profile and then execute the billing. Okay. So tomorrow we'll continue to see the next activity. I think RTP interface you might have understood today, little more clarity than yesterday. And if you already done it in the system, it is good. Otherwise, you can do it today also. You can try today also. Okay, let's see.